Hey everyone, my name is Ronak, back with another video, and this is the fifth video in the interview preparation of the data structures and algorithms using Python. So till now we have learned a lot of concepts, and today we are going to cover something that will actually give you an edge and take you up a notch for solving all the array problems, which is essentially sliding window algorithm. So sliding window algorithm is, I would say, certainly a type of algorithm that gives you edge over the other problem solvers. Till now, we have covered a lot of things in array, understanding the arrays, how they work. Now, let us look at an example array. So, first, let us understand why do we really require sliding window algorithm? Because whenever learn something, understand is that reasoning is the most essential thing. Alright. So, assume that you have an array. Let's say 1, 2, 2, 2, 1, something like this. And now you are asked to perform an operation in this array that requires you to work with sub arrays, something like this. Okay, so multiple type of arrays. Okay, so this one, this one, this one. In such a scenario, this type of problem can be tackled pretty much using for loops. But multiple for loops. So n number of for loops. And this actually gives you, I would say, exponential time complexity. So if you have, let's say, number of 2 for loops, certainly your time complexity will be order of n square. And similarly, as this number grows exponentially, it is going to be order of n raised to n. So this becomes a very difficult problem to tackle. In such a scenario, sliding window gives you an edge because it is linear. It works in order of n time complexity. And solving using sliding window algorithm, I would say, is pretty much difficult from a perspective of a very beginner. So I will try to explain all the concepts that are there, and then you will require a lot of practice. Personally, I required a lot of practice. Okay, I don't know about others, but I can assure you that, okay, this was the only topic where I struggled the most. Because even though it is easy to understand the concept, writing code becomes quite tricky. So till now we have learned 2 pointers, which I would say is the basic that can be used. Okay, so whenever we have to deal with an array of certain elements, we use 2 pointers to perform an operation. This is good. Okay, this is good, but this cannot be used certainly for sub arrays. But what if we could? Okay, so you can keep a track of these 2 pointers and create a window. Essentially, if there are n number of elements in my array, and if I try to keep a track of the window, this actually becomes a sub array. So this is the technique that we'll be using. And certainly, if you ask me, I can assure you that if you are able to solve a lot of problems using this, and there is a high, I would say there is a very high possibility that you are going to encounter a question from this. Okay, you are going for, let's say, very reputed companies. They will go into the depth of the sliding window algorithm because enforces you to work with the time complexity. So most of the problems that you are going to tackle in the section of the Leetcode will be certainly medium level questions, medium and hard. There are rarely any easy questions. Okay, and those easy questions can be pretty much solved using 2 pointers itself. Sliding window requires you to use the 2 pointers to our advantage to form window, and this window itself acts as a subarray for solving the problem. Now let us look at the types of it. So there are 2 types. One of them is fixed window and another is variable. Alright, variable window. So essentially this suggests that throughout my array I will have a fixed window of the subarray where these pointers are never going to change. Okay, and this moves through the entire array. Okay, so let's say it is over here, then the position changes. So let's say, let us take an example itself. Okay, so let's say 1, 9, 8 and 2, something like this. And let's say my window size is 2. So it starts from 0 and 1. Then this window shifts over here. All right. First it was here, then it is now here. So 1 and 2 like this. So the size of the window, okay, the size of window is essentially fixed. It is not going to interchange at all. Whereas in the variable window, based on the situation, okay, so let's say 1, 2, 3, something like this. We take some examples, and let's say there is a size where it asks you that return me the sum where the every single element adds up to 6, and let's say this now adds up to 6. Okay, so in such a scenario the window will be like this, but later on as soon as it reaches 4, we are not going to get that subarray, so we will have to shift. So now again it changes over here and then here, something like this. Okay, so it continuously keeps interchanging. The size is never fixed. Size is never fixed. So this is variable window. So what we will do, it is, I would say, very hard to comprehend the concept just by looking at the things of how it works. Okay, so if we take some problems, we can solve it. So let us directly start with our Leetcode problem number 1 for today. So like I said, we will work with two problems, one with the fixed window. So this is going to be a fixed window problem. Okay, so the first problem in the fixed window is essentially going to be maximum number of vowels in a substring, of given length. Okay, so we will take an example to understand this problem. This problem will help you get the intuition of the fixed size window. So let's say you are given a string. Let's say something like A, B, C, I, D, E, F. And then you given, let's say, a number K. Let us consider 3. Now you have to return the longest substring. Okay, you have to return essentially the longest substring of the vowels that is possible. Okay, so substring indicates that you will have, let me use a highlighter, you will have something like, if you consider this as an array, the substring indicates the string within string. Okay, so something like this, a string within string. And in such a scenario, what we have to focus on certainly is getting a substring that has the highest number of vowels. So if you see, A and C are disconnected with B, so it is not going to be a substring of the highest number of vowels. But if you see these 3 I's, this is a substring of the continuous number of vowels. Okay, because essentially the vowels are A, E, I, O and U. So anything that falls into this, so all others are consonants. In such a scenario, these 3 I's are consecutive, so length of that substring, okay, is 3, which is highest. So maximum number of vowels in a substring, okay, in a substring of given length, so 3. So this output should be returning 3. How do you think we are going to tackle this problem? See, if we go with the brute force solution, pretty much we can say that okay, we will use for loops certainly, but again the time complexity is a concern. So time complexity will be, let's say, if we will most likely have to use 2 for loops, so it goes in order of n square. Okay, we have to bring it down in the linear time, order of n. So using this sliding window, we can possibly do this. And now let me write an algorithm for this, and then we'll go into the explanation. So what I am planning is to take an algorithm and then frame the question Using an example, this example itself, let us say ABC triple at EF, and trying to figure out it, and then we will code it, and finally we will apply it on the Leetcode. So, and start by maintaining an holder array, which essentially gives us the Boolean representations of vowels. Okay, so obviously when I pass it this string, okay, I pass it any string, it should give me a Boolean representation. Okay, so let's say Boolean representation of the every single word. So if it is a vowel, it should give me true. If it is not, it should give me false. As simple as that. And then we can use a certain set of variables, which is going to be, let's say, maximum count. And let's say one more variable as count. So these two variables essentially will have the starting sum with the size of the window. So this k is equal to 3 is a suggestion or is an indication that it is a window. It is a fixed window size, because you have to find a window of 3 vowels. Okay, so essentially it is a window and you have to work with that window. Okay, so if we take the summation of the values till that window, we will first receive the values with a certain number. Okay, a certain number will be there in the both the situations. Now we directly move on to the, I would say, for loop, and we can run a for loop. So let's say for I in certain range. So in the range of, I would say, if I take the length, I can minus the window size from it. So it reduces the computation. Okay, so I would say length minus the window. Don't worry, we will take an example to understand this concept very in a deep manner, and then continuously update the count. So we can say count plus, in my holder, I will check for the respective position of the for loop as well as the window, and I will also perform a subtraction in the current window. Okay, so my holder over here with the current window, this is essentially going to give me the count I have, and this updated count I can check. Okay, so I'll also check if that count is greater than my maximum count, which is a fixed holder. I can literally update it, because I'll just say max count, maximum count is going to be that count, and in the return I'll just, in the end, I'll return maximum count. So now this seems pretty much confusing, but we'll take an example. But this algorithm is the way it is. Okay, so this is your sliding window. I'm sorry. Okay, this is sliding window. Now let us take this example itself, which is essentially A, B, C, triple I, D, E, F with the k is equal to 3. So I should return the maximum count of the vowels in that particular substring. So starting with, we will create a Boolean representation of the array, which is essentially our holder. And this holder we can represent. So this is a vowel. Okay, so we'll make exact representation. If we divide it like this, we consider it as an array. In such a scenario, A is true, false, C for false. Then we have 3 trues. Why? Because we have 3 I's. Then D, which is again a consonant, false. In E, it is true. Then F, it is false. So this is a Boolean representation. Now we will take the sum from 0 to the k size, which is essentially my window. So this is going to be my window. Okay, as simple as that. If I add these elements, okay, since these are Boolean expressions, I'll get a number. So my maximum count is now 1 and my count is 1. Okay, my maximum count is 1 and my count as well is 1. Now I will start running a for loop, and this for loop pretty much runs from the length of the window. So 0, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements. So I'll subtract the window from it, which is 8 minus 5. I'm sorry, 8 minus 3, which is my window, gives me 5. So I'll run a for loop for 5 elements. Now my window over here is fixed. Okay, this is not going to change. This gives me an edge to compare with every single element. Okay, so sliding window, if you ask me personally, what I feel, it is a substitute element that you apply into something to gain something. Okay, it is not an independent code. And this is a fixed window example. Now I'll start running my for loop. So for I, we will maintain the count of I over here. Okay, so I is equal to 0 at the moment. I in the range of 5. First we check for this. So count, irrespective of anything, I'm going to add. So currently my count is 1. 1 plus the holder looks for I plus k. I is 0, k is 3, which is essentially going to be 3. So the position is stationed over here. Since this is true over here, this is going to be 1 minus holder of the I of the current, which is 1. So this is going to give me 1 plus 0. So count at the moment in this line stays 1 itself. If the count and maximum count, if the count is greater than maximum count, I have updated. Is it? No. Now we increment. So our for loop now is over here. Okay, so I is over here. And again, now this pointer removes. Now I'll again say count 1 plus holder I plus k. I is now 1 plus k, 4. So we are in the 4th position. It is true. So 1 minus current I, it is 0. Why? Because it is false. In such a scenario, this is going to be 2. So now I update my count to 2. Now we will check this condition. If the count is greater than my maximum count, yes it is. So we will update it. Now I increments, it goes to 2. I comes over here. And now this t will be now incremented. Now in this scenario, this is 2 plus holder of I plus k. I is 2, k is 3. We go to the 5th position. Here it is again true. So 1 minus the current position of my I, which is 0. So this becomes 3. I update my count to 3 and my maximum value count also updates, because if my count maximum is greater, I am going to update it. So it now becomes 3. Now we increment the I becomes 3. I goes over here. Now 3 plus 3, we go to the 6th position over here. So now again I'm going to check for my count, which is essentially going to be 3 plus max. So holder of I plus k. I currently is at the 3rd position, k is 6th. We check at the 6th position, which is false, which is 0, minus currently at the true position, which is 1. So we get 2. Now, is this count greater than the max count? No, not at all. But the count gets updated to 2, but max count stays the same. Now we increment the for loop. We go to the 4th position. So my true over here is now shifted. We are at this position. Okay, 0, 1, 2, 3, 4. And now we will say 4 plus 3. So again, we will go for the count. So count is currently 2. 2 plus holder I plus k. I is currently 4. K is 3. Go to the 7th position, which is true. So 1 minus the current position of 1. So we come at 2. So again, the count is the same. Max count is also not updated. Now we go to the last position. The for loop increments. So from the 4th position, we go to the 5th over here. K currently is 3. So 5 plus 3 is 8, which is our last position. So over here, we will say 2, which is the current value of my count, plus holder I plus k. I plus k indicates that I is essentially 5 plus 3. It is in the 8th position, which is 0. 0 minus the current position of I, which is 1. So this updates to 1. I decrement the count by 1. Now if we again check, is the count greater than the max? Not at all. So we return the max count. So answer is supposed to be 3. Okay, so this is the way it is solved. I have also said this in my last tutorial of hash maps, that please draw with your hands. Okay, I always underestimated it, but is, I would say, the best way to understand any code. Take an example of any problem and map it out using your hands and pen and paper. It is the best way to understand the problem. So let us write some code for this. Okay, so I have made now a new file which is max vowels fw, which is for fixed window. And now let us actually write some code. So I'll take it from the Leetcode, the basic. Okay, so class solution with the max vowels. So it takes one string s and then it takes k. Now let us start writing code. So we will say holder. Now this holder is the boolean representation. So I'll perform a list comprehension for it. So let's say character in let's say A, E, I, O and U. Okay, so character in this particular set, I'll say for character in the S. So now this gives me the representation of my holder. Now we will start with our window. So I'll say for I in the range of length of the S. Okay, so I start from 0 and I'll say count plus so okay, so first we will have to make count over here. So we had maximum count and count. So maximum count and count. And what I'll do is I'll say equal to, because both are essentially same. So I'll take this sum of S starting from 0 to k. Okay, because I require the boolean additions for the fixed window to start with. And now here I'll say count plus is equal to, essentially this is count is equal to count plus we will say holder, which goes for current value of I plus the k, minus the holder checks for the current position of I. So I'll get rid of this to make it much more simpler. And now here I'll say, now we have to always check. So if the count value has currently exceeded the maximum count value, if so, I'm going to update the maximum count, the current count. And in the end, we return the maximum count. That's it. So now let us make an entry point for this. We'll say main over here. I'll make an object solution of the solution. And here we'll now have to mention a string. So let us take the same example that we have taken. So which was A, B, C, triple I, D, E, F. So it should be returning us 3. And K is also I'm going to consider 3. So I'm going to print the maximum count, which is going to be sol dot max vowels takes S and K. So let us now run this. So I'll say pi max vowels. Okay, so we have an issue over here. Let us check. Okay, so this is holder. I'm extremely sorry. This is holder, not the string, because we cannot add characters. We can add the booleans. We again have an error. So let us check. So holder of I minus some error is there. Okay, yes. We will have to say minus k. If you remember, we have trained our for loop to run from 0 to 5. Okay, which was essentially the length of my holder, which was 8 minus the current window. Otherwise, it will start from the window itself. We are working on the sum of the window and we get 3. Okay, so let me run this again. It gives us 3. Now let us take this solution and paste it in the Leetcode. Okay, click on run. All test cases are passed. Click on submit and it beats. Okay, it says 97%. I would say 97.74% better than other Python users. So this is the way you solve this problem. So this was a fixed window problem. Okay, so this was a fixed window problem. Now let us look at the variable window pattern. Alright, so now we will work with variable window pattern. variable window pattern. So over here we are going to work with a very trivial and common problem. So again, both these problems are going to be the medium level problems. All right. So let us actually work with the problem. This problem is longest substring. Okay, longest substring without repeating characters. See, just remember, whenever you have something with substring or subarray, you are going to use sliding window. Okay, fix that in your mind completely. Let us take an example. Assume that you have a string, let's say ABC, ABC and BB, something like this. And you are given, let's say, okay, so essentially you are, let's say, not given anything. And you want to find out the longest substring without repeating characters. Okay, so the characters, if you check, A, B, C are unique. So essentially the size is 3. Then again you check over here ABC, which is 3. Okay, and there is BB. So this repeats. So we can forget this. So you check for, let's say, a unique characterization. Max count you have to return. Okay, so longest substring that is possible. Let's say if there is A, B, C, D, A, B, C and BB, something like this. The substring over here is going to return 4. This is going to be 3, which is unique characterization. In such a case, you are going to return 4. Okay, very easy. So how you are going to tackle this problem? Again, if we can solve this using 2 for loops. So that goes in order of n square, and we have to reduce it to order of n. For this, we'll now be working with variable size window. So let me write an algorithm for this, and then what I'll do is let us write an algorithm for this, and then what we will do is we'll start with the example and then code as usual. So here we will require an hash map. See, this was the only reason I covered hash map. If you see, very after keen observation, I would say I've came to the conclusion that for solving sliding window, you will require hash maps some or the other way. Okay, either you are going to require sets or hash maps to solve certain set of problems, certain type of problems, and 2 pointers is always used. Okay, for the I say variable window length. In such a scenario, it is very, very crucial that we cover these concepts. That was the only reason. In the last video, I could have covered sliding window, but I went with the hash maps. Anyway, so we will start with 2 pointers. So let's say left and right. Essentially both starting from 0. And we will have this empty hash map. Now, what I want to do is I want to check while right pointer is less than, let's say, the length of my string. And in this, I want to add all the elements. Okay, so what I'll do in my hash map, I'll take the element of the string, whatever string I have, and I will give it the element in the right pointer and also store the position. So I would say index where currently the right is working. So essentially, when we take example, this will get clear, but understand this, that the key over here is the element itself, which is going to be a character of the string, and the index is going to be a value. And then we will also have variable as a result. We will initialize it with 0. And now we will continuously check the result for the maximum value of the result existing and the right minus the left pointer 1. So this gives me the essential position of my current window. Okay, this is the way you do it. And obviously this is a while and not a for loop. I will have to increment the right pointer. So essentially in Python, plus is not there, so +1. And we will also have a base checking condition over here, that if the current right pointer in my string is in hash map, okay, if it is already available in the hash map, I don't obviously have to add it, but we will update the left pointer. And here we will say maximum of the current position let us say that element in the hash map plus 1 with the left. Code pretty much like this. This is a pseudo code and it seems complicated, but this is the way to do it. When I will give you an example, the intuition will get clearer. In the end, we return the result. So let us start working with an example. This will working with an example will clear all the things. Okay, so whatever confusion you might be having, it will be cleared. Trust me. So let us start working with the Leetcode example itself, which is essentially ABC, ABC, and it is BB. So working with our example over here, our left and right pointer starts from here. So we will maintain a count for it. So left and right, and also we will maintain the result. Currently all of them are at 0. And then there is your empty hash map. So you first check that while right is less than the length of the string. Yes. If the right is in hash map, is it in the hash map? No. Currently nothing is in the hash map. So I add it. Okay, so I'll say a with 0, which is my current index. Then I'll calculate the result. So the way the result is calculated is you first take the current result 0, then you do right minus left, which is 0 minus 0, and add 1 to it. So plus 1. So this is 0, 1 essentially. So your result gets updated. So maximum value is 1 over here. In such a scenario, I'm going to update the result to 1. And then I increment the right pointer. Okay, so I increment the right pointer. Now right pointer comes over here. Okay, it leaves left. Now again it is calculated. If the value, the B is in my hash map, no, I'm going to add it. So I'll say B with the current index, which is 1 of the right. Essentially it is the right index. Then I'll again take max. So current result is 1. Now right minus, again I would do 1 minus 0 plus 1. So this is essentially going to be 1, 2. So result is updated to 2. Understand this, that whenever you get a unique character, the first time the result is going to get updated until and unless these are without the repeating characters. Next step is the right pointer is also incremented. Okay, so now right goes to C. Now again it is checked. Is C available in my hash map? No. So I'm going to add it. C with the 2. It is added. Now I'll again check the result. Current result is 2. You take the right, which is going to be 2 minus current left, which is 0 plus 1. So this gives you 2, 3. So essentially result is updated to 3. Then you check the last line. Right pointer is again updated. It becomes 3. It goes in the third position. Okay. So now you will start having the repeated characters. Okay. So A is now repeated. So if the currently pointing character of the string is in the hash map, yes, it is available. I am going to now update my left pointer. Okay, I'll take the max of the element in the hash map currently where my right is held, which is essentially the current right element. So if we see 0, 1, 2, 3, 4, 5, 6 and 7, currently the right is at 3. So 3 plus 1 and the current left element. So it is at 0. So this gives you 4, 0. So 4 is maximum. You directly update the left pointer over 3. Okay, so now left is 4. Okay, left pointer is now updated. So we actually saved a couple of steps. We directly do this and transfer it over there after the so that we don't have to go every single time and check for every single character. Okay, if you use a set solution, it is going to be time consuming. For hash map, it becomes pretty much easy. Okay, now this has happened. Now again we resort to our right. So right with the current index, we have done this over here, which is at the third. So 3 will be added. Okay, 3 is added. Current right index is added. Now again I calculate the result. My current result is 3. Now again I will over here do right, which is 3 minus the left, which is 4 plus 1. So this is essentially 0. Okay, so 3, 0. So result stays 3. Why? Because we had a repeated character. That is the reason the result has not been updated. Understand this. Now I increment the right pointer. Okay, so now right pointer becomes 4. Okay, so right pointer comes over here. Now again we check for the B. Yes, B is available. I'm again going to work with my left pointer. So element hash map currently +1, so it becomes 5, and the earlier one which is 4. So maximum of it is 5. So left pointer is updated. Left pointer becomes 5. Now we move on with the next step earlier that we have performed. The B position becomes 4. Then I take the maximum of the result. So 3 comma current position right, which is 4, minus current position of left, which is 5, plus 1. This is essentially 0. So 3 comma 0. Result stays the same. I have the right pointer by 1. This line essentially. Okay. Right pointer is always updating. Right pointer becomes 5. So now this right is over here. Again, I'm going to go into my hash map and I'm going to say if the C is available. If the C is available. In such a scenario, I'm going to update the left pointer. Left pointer now becomes 6. Okay, left over here. Now I'm going to make the updation. So over here the C is now resorted to 5. Okay, which is my current index. Now I'm going to take the result. So 3 along with 6 minus 5 plus 1. So 3 comma 0. Again, I'm sorry, it is not 6 minus 5. It is essentially 5 minus 6. Okay, so right minus left. 3 comma 0. 3. Again, it does not change. Result stays the same. We increment the right pointer. Right pointer becomes 6. Right pointer is now here. Again, now we are going to check. Is the B available? Yes, the B is available, no doubt. So in such a scenario, I'm going to update the left pointer. Left pointer now points over here. So till repeated example, but if again there was a new example, it would have jumped directly. Okay, now B is now updated. B becomes 6. Okay, so left pointer essentially is 7. And now we take the maximum of the result. So maximum of the result. So current result is 3. So it is again 6 minus 7 plus 1, which is essentially again 0. So 3 comma 0. In such a scenario, the result stays the same. I update the right pointer. Right pointer now goes to 7 over here. Right pointer is now updated. Now again we will make a check. So now this is where it essentially is going to end, because the right pointer would be less than the length of string. So this is the way it ends. So get result as 3. Okay, because since the left pointer has already overseen the last element, we don't have to update it anymore. Okay, I can keep it in the earlier position. So my result is equal to 3. Now let us write some code for it. So I made a new file which is longest substring vw, which is variable window. And now let us start. Okay, let us start by writing the required amount of code. So we will have a left pointer, we will have a right pointer, we will have a result, we will also have a hash map. Okay, and let us also give it n, which is essentially, or we can just keep it. Okay, so never mind. So 0 comma 0 comma 0, and you will provide a hash map. Now over here we will say while the right pointer is less than the length of my string, I want to perform something. Okay, so if the current right element is in the hash map, okay, is available. If it is only available in the hash map, I want to update my left pointer. So left is now essentially going to be hash map with the s of right plus 1 and the older left pointer. Okay, and now here I'll say hash map with the s of right. So irrespective of anything, I'm going to add the current index of my right. And here we have to always check for the result, where I consider the max value. So first we take the result, current result that we have, and then I'll perform right minus the left plus 1. Okay, and then obviously we will increment the right pointer all the time, and in the end I'm going to return the result. That's it. So let us write an entry point for this. So I'll make an object of my class. and then now let us give us it a string. So let's say ABC, ABC, BB, and we'll print the result. So I'll say SOL for the length of the longest substring, passing it the S. I'll say pi with the longest substring. It gives me 3. And now intentionally let us try to make A, B, C and D over here. It gives us 4. So it is working. So let us now copy this code, paste it in the Leetcode, run it. All the test cases are passed. Click on submit. Okay, it has successfully executed. So this is the way you deal with the sliding window. Obviously, there are a lot of problems and you will require a lot of practice. Trust me. It took me a way long time to understand sliding window, because it does happen. Okay, some people don't understand linked list, some people might not understand recursion, some people might fail backtracking, some people might not understand intervals, some people are very bad with binary search, some people don't get the intuition of sorting. It is person to person independent. In my case, sliding window was the most horrible thing that I personally have faced. Okay, until I started discovering the later things, it with the practice and revision, I say that it being quite easier to understand. And even I'll try to provide some problems for your practice, so you can practice a lot. Most of the questions you are going to get are to be medium and hard level. Okay, there are a very I would say rare possibility that you will get a question which is of easy level, and easy level questions I would say can be pretty much solved using 2 pointers. Rarely there is, I would say, an implementation that would enforce you to or emphasize your skills to use sliding window. It is not possible practically. Okay, so all the medium level questions you can solve in the Leetcode. And if you ask me, certainly I don't think this is where we stop. Again, in the next upcoming tutorials, I don't know what I might be covering. I'll try to link everything in such an order that you will be very well aware of what you're doing at least. Okay, so we have covered first array, then we went into 2 pointers, then hash map, and now today's sliding window, which has essentially used everything that we have done till. Okay, so a very, I would say, great link in your mind has been implanted. And obviously I'll give all of this material to you in the description box below. It is a GitHub repo. You can click on the link and have the material. Okay, so please practice as much as you can. And if you like my content, please do subscribe to my YouTube channel and share this video with the people who you think should learn this concept. Okay, so, and I hope this video turns out to be very helpful to you in your interview preparation. Okay, so we'll stop for here and I hope you might have learned something or the other. So thank you for watching. Goodbye.